Greetings everyone, welcome back to video lecture series on VLSI design. My name is Dr. Prashant Bachanna, working as assistant professor in the Department of Electronics and Communication Engineering at Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in this video lecture, we shall be learning about the types of the Mosfet, that is different types of Mosfet, PMOS, NMOS, PMOS and CMOS. So in this video, we will be talking especially about these two types of the transistors. So in the previous video, we have learned about the structure of the MOSFET. So once we design, like the MOSFETs are fabricated on this silicon wafer, as you can see in the diagram here. Okay, so we can once the transistors are fabricated on the silicon wafer, as you can see in this figure. So the types of the MOSFETs, so we have two types of MOSFET, that is N-channel MOSFET and the P-channel MOSFET. In the N-channel MOSFET, we have two types again, that is enhancement type transistor, enhancement and depletion type. And in the P-type, we have again enhancement type and depletion type mode transistors. So we'll see this one by one. So this is the structure for the N-channel planar enhancement transistor, that usually we call it as NMOS. So in the NMOS transistor, the majority carriers. So as you have previously seen in the previous video, we have seen that the transistor, okay, the MOS transistor, either it may be a PMOS or NMOS, it is having four terminals. Okay, so the terminals are source, gate, drain, and the substrate, the fourth one. Okay, so here also you can see there are four terminals are there, that is source, gate, drain, and the substrate. This is the fourth terminal which is called as substrate. So in the P-type substrate, in the N-type MOSFET, that is what we call it as NMOS transistor, the majority, that is the source and drain terminals are heavily doped with N-type electrons. That is why it is called as the N-type transistor, and here the substrate is a lightly doped P-type semiconductor. Okay, so in the NMOS transistor, the source and drain are heavily doped with the electrons. That is why it is called as NMOS transistor. Okay, and the P-type substrates are lightly doped, that is holes. So this is about the structure of the N-channel enhancement type transistor. So the difference between the enhancement type transistor and depletion type we have seen in the previous video. So in the enhancement type, there will not be a channel. Channel will not be present in the beginning. Whereas in case of enhancement type depletion type transistor, the channel will be present from the beginning. That is the difference between the enhancement type and depletion type transistor. Okay, so we have seen N-channel MOSFET. So now we will enhancement type transistor. Now we'll see P-channel MOSFET, that is which is called as usually PMOS or PMOSFET. Okay, so simply we can write like this, PMOS. So which is so in the PMOS transistor, exactly the source and drain. Here also we have four terminals. So here the source and drain are heavily doped with the P-type material, that is holes, and the substrate is doped with the few numbers of lightly doped electrons. Okay, electrons here. So that is the difference between the N-type channel and P-type. The difference is that if the source and drain are heavily doped with the P-type transistor holes, then that transistor is called as the P-type transistor, and the substrates are lightly doped with the electrons. So here also you can see, since it is an enhancement type transistor, there will not be no channel will be present between the source and the drain in the beginning. So we have to create the channel by applying the voltage. So that is the difference between enhancement type transistor and the depletion. So here we have seen now N-channel MOSFET and P-channel MOSFET. So now we'll see the depletion type transistor. So here you can see the N-channel depletion mode transistor. As you can see, the channel will be established here. That is the only difference here. Okay, so Here in the N-channel depletion type transistor, the source and the drain terminals are heavily doped with the N-type material, and here channel length is L. That is called as channel length. So the channel is present here. Channel is established in the beginning only. Established in the beginning. That is the difference between the enhancement and depletion. So in the depletion type transistor, in the beginning only the channel will be present and it is shown with the length of L. Okay, so here also 4 terminals are there. So since it is an N-type transistor, so the source and drains are heavily doped with the why we doped heavily, because we required good conductivity between the source and drain. So since we require good conductivity between source and the drain, so for this reason we have to heavily dope the electrons in this source and the drain region, and the p-type that is the substrate terminal here lightly doped, lightly in the sense few transistors will be present. So this is about the N-channel depletion type mode transistor. So here we will be having length and the width of the channel. That is the only difference between the depletion type. Again, so for the P channel, so as all of know, it is called as PMOS. Since it is in the PMOS transistors, all of you know, heavily doped source and drain terminals are heavily doped with the holes here. Heavily doped with the holes. So such and the substrate region is lightly doped with the electrons, exactly opposite that of the N-channel depletion mode transistor. So the only difference between the depletion mode is that the channel is already present here. Channel is present in the beginning only. Whereas in case of enhancement type, the channel will not be there. So channel with the length L and width W. So that is the difference between the N-channel MOSFET and the P-channel MOSFET. So we have seen the different types of the transistors, that is mainly PMOS and NMOS. So now we will see the symbolic versions of this, because every time we cannot draw the diagram. So symbolically these transistors are represented. Like you will see about N-channel enhancement type. So the N-channel enhancement type, so we'll remember this one. This is most widely used, this one. So we have source, gate and the drain terminal here. Okay, so this source and drain are interchangeable. Then if the arrow mark is towards outside, towards the source here, so this is called as N-channel. So this is a symbolic representation of this one. So if the arrow mark is outside, so this is gate, source, drain. So if the arrow mark is outside, so this is a symbol for the N-channel enhancement type transistor. Okay, so in the P type, if the arrow mark is towards the gate terminal, then this is a symbol for this. So we have terminals here, source, gate, drain. Substrate is not shown here. Okay, so VSD is the source to gate voltage, then VSD is the voltage which is flowing in the from source to gate, and the ID is the current which is flowing from source to the drain. So this is about the N-channel enhancement type MOS transistor, and these are the symbolic representation of N-channel P-channel enhancement type transistor. In the depletion type, what will be the difference? So we will be showing a channel here. Okay, so this is NMOS. So as we know, if the arrow is outside towards of the source terminal, if the arrow is outside, this is NMOS, and the only difference between enhancement and depletion is the channel is shown. So here the channel is shown with a thick line. That is the only difference between the enhancement type and depletion type. Remaining all the symbols and notations will be same. And this is about again the same P channel. If the arrow is towards outside, so see in the previous one, here we have taken source and here drain. Whereas in the previous one, in this source is here, drain is here. So here we should remember one thing: the source and the drain terminals are interchangeable. Okay, so we can exchange the source and drain terminals. That is the advantage of the MOSFET. Okay, so the arrow is outside, and we will show one line here. Thick line is shown, which shows there's a channel of presence of the channel in the between the source and gate gate terminal. Okay, so this was about the p-type transistor and the n-type transistors and their symbolic notations. And now MOS can be used as a capacitor, so we'll see that. So metal oxide semiconductor we use, and semiconductor material, and this is the substrate body, and the thickness of this metal oxide what we use is we will use basically silicon dioxide. Okay, and the thickness of this is TOX. So what will happen is that when we apply voltage, okay, when we increase the voltage, okay, the current will increase, okay, then the thickness oxide TOX will be reduced. So that is why we can say that when there is a current flown in the transistor, it acts like a capacitor. So it will store the charge. Okay, when the transistor is on, then when the transistor is off, whatever it has charge, it will discharge. So we can say that the MOS transistors acts as a capacitor. So when the current flows between the transistor, so the capacitor is charged, that is which is present in the silicon dioxide layer, that is of the thickness TOX. So when it is off, it will be off. So this is what, see, when current flows, the electrons will flow and it will be charged. So that we can say it as MOS as a capacitor. So we can say MOS acts as a capacitor. So so this working we call it as the accumulation of electrons near the gate terminal. So there are three regions of operation here. That is, the first region of operation is called as accumulation region. So if the gate voltage is greater than 0, so there are three types of three regions of operation. So the first one is the accumulation region. So if the gate voltage is greater than 0 volts, then we say that the transistor is in the transistor acts as a capacitor. So there will be accumulation of electrons near the silicon dioxide layer. So this we call it as the accumulation layer. Then the next two types are depletion. So if the gate voltage is less than 0, so we call that the transistor is in the depletion region. Okay, so there are three. If the gate voltage is greater than 0, we call it as accumulation region. If the gate voltage is less than 0, we call it as depletion region. So depletion region will be formed here. That is the second region of working. So we can say that the MOS transistor works in three regions. So the first region is based on the voltage applied. If the VG is greater than 0, VG is less than 0, and VG is greater than threshold voltage. So if it is less than, we call it a depletion region, and if the gate voltage is much less than 0, it is called as inversion layer. Okay, so this was about this one. Okay, so if the gate voltage is too much less, so now we will just summarize it. So the transistor works in three regions. If the gate voltage is less than 0, okay, so the holes, there will be accumulation of the electrons, okay, near this terminal. So this region we call it as, there will not be any flow of current. Okay, so we call it as accumulation region. If the gate voltage is greater than, if you increase little bit the gate voltage above 0 voltage, so then the depletion region will be formed here. So here also there is no flow of current, but in order to transistor to work, our gate voltage should be much greater than 0. Okay, so that voltage we call it as threshold voltage. So at the time, the inversion of electrons and holes will occur. That is, electrons and the holes will get attracted to each other, and inversion layer is formed, and the current starts flowing in this inversion layer. Okay, so this was about the three regions of operation, that is accumulation region, depletion region, and the inversion region. Okay, so here we have to remember that the transistor, okay, so why we call this terminal as gate terminal is because by applying the gate voltage, what we can do, by applying the gate voltage we can control the operation of the transistor. That is why it is called as gate. So we can apply different types of voltages, VG greater than 0, less than 0, or much greater than 0. So on the basis of that, there are three regions of operation, that is depletion region, accumulation region, depletion region, and the inversion region. Okay, the same thing which has been mentioned here. Okay, so we'll go in detail much about the working of this transistor. So the MOS transistor, whether it may be an NMOS or PMOS. So here we have taken an example of the MOS transistor here. Okay, so here we have taken an NMOS, for example. So here the working is explained in the 3 levels as I have seen in the previous slide. So we'll go in detail. In the first case, the gate voltage is less than 0. Gate voltage is less than 0. So when we apply voltage less than 0, what will happen here? Okay. So the accumulation of electrons near the gate terminals will occur. In the second case, we'll apply the gate voltage greater than 0, but little bit will increases, but less than the threshold voltage. So here we should remember VT is called as the threshold voltage. So threshold voltage is a voltage at which the transistor is on. At which the transistor is on. So that voltage we call it as threshold voltage. Okay. So in the second case, we will increase the gate voltage greater than 0, but it is less than threshold voltage. Okay. So in that case also, what will happen? A depletion layer, as you can see here, there is a depletion region is formed. Okay, near the channel. So here also there is no flow of current. So in order the transistor to work, so what we have to do is we have to apply the gate voltage greater than the threshold voltage. VT we call it as threshold voltage. Okay. So let us say 2.7 volt is the threshold voltage. Okay. So at 2.7 volt, the transistor will be on. Okay. So if it is less than 2.7 volt, the transistor will be in a depletion region, maybe 2.2 or whatever it may be. Then if it is less than 0, then the accumulation of electrons will happen near this channel. Okay. So this was about the working of the transistor. So as we can see here, if the gate voltage is greater than the threshold voltage, then only the transistor will be on, and the inversion of electrons, that is the electrons get attracted to the holes, and an inversion layer is formed here. As you can see, an inversion layer of electrons, these are holes, an inversion layer of, these are the layer of the, so an inversion layer is formed with the help of the electrons in the holes. So here there will be a circulation of current here, circulation of current near this channel, and the current starts flowing in this channel here. So this is a flow of current like this. The electrons will be moving here, the holes will be. So the current starts flowing in the inversion layer, and we can say that the transistor is on and it's working. This was about the structure of the MOS and the working in detail. Okay, MOS operation we have seen. Okay, the same thing is been shown here. Okay, so we can apply the VGS is called as gate to source voltage. See here. See, this is gate, this is source, this is drain, right? So this is N-type transistor, let us say. So VGS, the voltage which is flowing here, we call it as VGS. Okay, then there is a VDS. The voltage applied between VDS is called as drain to source voltage. Okay, so based on the drain to source voltage, so we can again explain the operation of this one. So here a channel is formed if the gate voltage is less than 0. Okay, so first what we'll do, we'll apply VGS greater than threshold voltage, and if VDS is 0. Okay, in the first case we'll make VDS equal to 0, no current flows. We'll make VGS greater than VT. In the second case, VDS minus VDS is less than VGS minus VT. Okay, so this is called as non-saturation region, and in order the transistor should work, that this VDS should be greater than VGS minus VT. So whatever the voltage we are applying between this gate to drain terminal, that is VDS should be greater than VGS minus VT. Okay, so this region we call it as saturation region. So now we can say that the transistors operate in the 3 region, that is saturation region, this is non-saturation region, okay, and this is called as pinch off region. Okay, so if the VDS equal to 0, pinch off region. If the VDS is less than VGS minus VT, we call it as non-saturation current. Here in the non-saturation current, okay, a small current flows here. Okay, a channel is established, and here what we can say, in the saturation region, the channel is established, and the moment of the current starts flowing. That is, the VDS is greater than equal to VGS minus VT. So this is The operation of the MOSFET in 3 regions, that is pinch-off region, non-saturation and saturation region, based on VDS is greater than VGS minus VT. Okay. So already we have seen the depletion type transistor. In the depletion type transistor, the channel will be present in the beginning only. Okay, so that we have to remember. So in the depletion type transistor, the channel is established in the beginning only. In the N-type enhancement type, the channel will not be present. Okay, so this was about the working, the types of MOSFET, the main 2 types. In the next video, we will discuss about the CMOS transistors. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.